Okay, give me 5 minutes.
Okay.
Okay.
All right, I just shared it in a bunch of channels.
Okay, shall we start now or should we just wait 5 more minutes?
Maybe like a few more minutes, see if anyone else pops on.
Cool.
Thanks for putting this together, by the way.
No, that's fine. I mean, it helps me to, like gather my thoughts together and it helps me too. So,
Cool.
yeah. So what do you do? Are you a full-time developer or?
No, I'm trying to become one.
Right.
I'm a customer service manager for a software company.
Oh,
So, but
cool.
I do like coding as a hobby, and I really started getting into it with this class.
Right. Is that
So it's been fun.
your first course in coding or?
No, so I've taken other courses like I got pretty good with HTML, CSS, JavaScript. I started getting into Python a little bit, um, and I've done some other stuff. But this is like my first exposure to Android or like mobile development in general. I've never done it before, so I've
Cool.
never really done Java before either. So
Yeah.
it's been like
This is
kind of hard, but but good.
I started on iOS.
Hmm.
So basically, I started learning Swift, and then I saw the scholarship, and then I just
Hmm.
jumped on it, and then next thing they approved it, and then that's how I got into Java.
Cool.
Yeah.
So same with you. You haven't really done Java in the past either,
Nope.
huh?
Nope.
That's cool.
Not even one line of Java. So
Yeah.
yeah. Okay, we should start. Um,
Okay.
so content provider. So today we're going to talk about content providers, especially the CRUD operation. So create. Oh crap! I forgot what's R again. Remove, update, and delete.
Hmm.
So so the way I structured this PowerPoint is kind of like a skydive. So it's kind of like going from 100,000 feet down to about 10 feet or 10,000 feet, and then 100, and then 1,000 feet, and then 500 feet. So each level is a different abstraction. Okay, so from the 100,000 feet, we're just going to talk about the basic purpose of the app, and then at
Okay.
10,000 feet, we're going to talk about like the components that are involved and their roles in their in the app, and at that level, it's only very little coding involved, and then at the next level, 100 at the 1,000 feet, we're going to look at each class in the app and discuss what they do. So we're going to see some more code. and then at the 500 feet, that's the full-on coding part. Okay, so at the basic level, basically what you're looking at is a to-do list app where a user tapped on the fat button, and then it brings the user to a add item screen. And then basically what I did is just typed in hello, and then I clicked add, and then it shows up on the list to the right. So it's very basic, very, very basic. And you see that a lot in other apps as well. So so jumping down to the next level at 10,000 feet, what is actually happening is when the user first launches the app, right, it communicates with a database, right? So say, hey, do you have any data for me to display? Well, if the user just only installed the app, it wouldn't have any data, right? It wouldn't have any to-do list items, right? So there's nothing going on. And then as soon as the user taps on the fat button and this new activity pops up, and then it tells the user to write down a to-do list item. And when you click add, it will send the added item to the database. And then upon arriving back to the main activity, the database will give, or the main activity will ask the database to give all the stuff to me, right? So it's querying. So let's focus on this part, the highlighted part, okay? So you have an on create screen, and you have a database, right, at the far top right. Okay, so you want to know what's going on in between this link, right, from the on create to the database. Okay, so the first thing is that your main activity needs to initialize a loader, right? Now, the reason why we want to initialize a loader is because you want the querying to be done in a background thread. Because, like, let's say, for example, like if you have a database for like the DNA genome of a human being or something, and you want to know what is the chromosome code at position 23 or something, you're going to get a lot of information back, right? And you don't want to do that on the main thread because it blocks the UI, and it blocks the UI, and then it freezes the phone, and that's why we want to use a loader to do that. Okay. So the first thing is to communicate with the database, you need to initialize a loader. Okay. So initializing a loader is very simple. So on the on create, you call the get support loader manager.init loader. Now the get support loader manager, the thing that's returned from it, that's only a single loader manager. Okay, you're getting a loader manager back. So in the previous, I'm not sure if you were there or not, Ryan, is that I've talked about async test loaders in my other videos. Mm-hmm. So let's just call this guy Steve, right? He's a loader manager, okay? And he is responsible to create a loader, right? So he creates a loader, and then this loader exists in a worker thread, okay? So you, as a programmer, you don't communicate directly to the worker thread or to the worker. You communicate to the worker via the loader manager, okay? Always remember that. There's always a separation between your main thread and your worker thread. If you want to communicate one thread to the other thread, there has to be some kind of interface, right? So, right. So the loader, the loader queries the database. Okay, so do you have anything for me? And he comes back, oh yeah, sure, I have some cursor for you. So basically, a cursor is like a table, right? So when you query, like, say for example, if you have a database full of books, and you want to query, I don't know, like book that starts with a letter S or something, right? It comes back with a table, and that table representation is called a cursor. Okay, so it comes back with a cursor, and then upon this guy's finished, it calls the super dot deliver results, and that calls. Hold on, I'm going too quick. Okay, hold on. Before going to do that, once this is finished, this is going to be cached. It's going to be cached because it saves you from. So whenever the user goes in the background and it comes back again, and if the cursor is still the same, you don't want to reload everything, right? You just want to go straight to deliver results, and you don't have to go through the loading part again. So this is why we have a cached memory. So it does that, and then it calls the super dot deliver results. So super dot deliver results calls the on load finish in the loader manager, and then it gives back to the main activity on the on load finish. Okay, so I just want to stress that the loader manager is just basically a set of callbacks, right? So whenever you want to do something in the background, the only guy that you will always interact with is the loader manager. You never ever communicate to a loader, right? Because loader is on the other thread. You can't communicate to it, right? So I have this diagram here, is that when you have a main thread and a worker thread, the variables inside of each thread is private to that thread. You cannot ever communicate. Well, you can, but in a normal situation like this, you cannot communicate to each other. The only way you can communicate each other is to have a guy named Steve or some other guy, like just have an interface that is controlled by the operating system, not you, right? So there's always a membrane in between threads. Okay. So now we're going to look at this part here. Okay, so this part is pretty important.
So the worker communicates back with a callback, right?
Yes. So once the loader finishes, it tells the loader manager, and then the loader manager tells you as a programmer through a callback, right? So once this is done, super dot deliver results, it's called, and then the onload finish gets called. It comes back with the data, and then you can do whatever you want on that. Now you can do whatever you want on the onload finish. It's because the onload finish is called on the main thread, so it's safe. It's thread safe at that point. Okay. So in a nutshell, basically what you're doing is that from a on create, you initialize or you reset a loader, and then it calls this guy Steve, and it calls Steve, and then Steve tells the worker what to do, right? Once the worker finishes what he's supposed to do, it comes back, or it tells Steve that, hey, I'm finished, here's my data. And then Steve will tell you that, hey, the worker is finished, what do you want to do with the cursor? Okay. Now, from the main activity all the way to the worker or the loader is impossible. You cannot do that, okay? You go through Steve. You always need to go through Steve, okay? So let's have a look at the worker and the content provider, right? So I guess this is a standard practice, but if you have a database inside of your app, you always want to wrap it using a content provider, okay? So this is the part of the loader callback. So the loader callback, the first method it's going to call is the on start loading, right? So here, since the loader doesn't have any cached data, it will check. Okay, so it checks to see if there's like any cache data. If it doesn't have any cache data, then it forces the loading process. So what this force load method is doing is that it's called the second one, which is the on something. Hold on, can't remember the name. Yeah, load in background. That's right. So this force load method calls the load in background method. Okay. But if this method if this method has a cached memory, then it will just call this straight away. It will call this straight away, and it triggers the callback from the loader manager, so it doesn't have to do that load in background process. Okay.
Oh, okay.
So yeah, so since it is started for the first time, there won't be any data. So then what the load in background will do is that it contacts the content resolver. And you can think of content resolver as like a waiter or a waitress, right? You send the information to this waiter here, and then this waiter, it's kind of like you're ordering food, right? So it takes your order. So in this case, load in background, you are saying to the waiter, say, hey, I want to query this. Okay, I'm giving you this URI so that you pass this to the kitchen. The kitchen is the content provider. Okay, so the waiters write down what you want, and it goes to the kitchen and delivers what you want. Okay. So once the waiter goes inside of the kitchen, right, it needs to see if the URI is matching or not. Assuming it matches, or assuming it's correct, then it will return with the cursor, right? So it returns with a cursor like this. Or if the URI couldn't be found, or if it's invalid, you'll get an exception. Okay. So, is there any questions at the moment?
I don't have any questions. This is Steven. I don't have any questions right now.
Okay.
Yeah, I think I'm good for now.
Okay, cool. So, so what does the content provider made of? What makes a content provider? So in the app, you got 3 .java files, right? You got the task contract, the task DB helper, and the task content provider. Okay, so the first one, this is just basically a file full of static strings. Okay, so you got this public static final, which is a string. This one is also a string. It's a string. And the reason why you need these is because you use this class, use this task contract to help you build your database, right? So if you can see here, it uses all of these static properties in here. Can you see? Mm-hmm. So this guy relies on this guy, okay? And also, so from the task content provider, it needs the task DB helper to initialize this guy here. Okay, so it's very important because, like, the way they structure it is very good. I think it's very clear. Is that you specify the static strings in one class so that you can use this class to build up your tables in your database. Okay, so once you got that down, you can initialize this guy here inside of the task content provider. Okay, and then the way this is initialized is through the onCreate method. So each content provider has an onCreate method, and that's where you initialize this private variable. Okay. Now, one of the example of the CRUD methods is the insert, right? And I've seen many people are confused about this URL matching static method. So basically, when the waiter comes in and it gives the URI to the kitchen, it needs to check it first, because you cannot just give any URI and expect a return, right? So so you need to pass in the right URI in order to get the right response back. So this is what the URI matcher does, is that it checks the incoming URI against different cases. And then if it doesn't match, then it will just give the waiter back a exception. It gives the waiter back the exception. If it passes, then it gives back the cursor. If it fails, then it gives the exception. Okay, so let's have a look at this. So this is the method, the URL matcher. So basically, that's all it is. You just specify the correct format of the URI, and then you use this method in the switch statement. Okay, so again, so the main activity gives the URI to the content resolver, and it's kind of like the waiter is going to the kitchen and hands it to the chef, right? If it's successful, then the cursor will come back. But if it's not successful, then you have an exception, right? So this CRUD method, the the insert, query, delete, update, whatever, it's you can think of it. It's safeguarded by this build URI matcher. It has to match the URI that you specify, right? So it is safeguarding this.
So it's like you're asking the waiter to get you a certain, like without seeing a menu, you're asking for a certain type of food, and then he goes to the kitchen, and if that food doesn't match what's on the menu, then he comes back with nothing.
Yep, that's it. So we've covered this. Now let's look at the inserting part. So this is inserting to the database. So again, like hopefully you guys can see a pattern here, is that like I do see a pattern, is that you as a programmer, if you want to communicate to something that's inside of the system, like inside of the OS or the Android framework, there's always something in between. Like, do you guys notice that? It's always going to be something. Like here is the content resolver. And then in the loader part, in the async loader, you got the loader manager. So it's always a interface in between you and the system, right? So it's something that it will help you in the long run, because Android is a framework, right? You need Android framework to build Android applications, right? Now, there are a lot of services that the Android framework can provide you. But the thing is, you don't use it directly, right? There's always a interface, or there's always a singleton that you have to use as a gateway to get that service. You cannot just use the service right away or directly. There's always has to be some kind of a middle person, right? In this case, it's a content resolver. And when we're dealing with async task loaders, we are dealing with the loader manager or Steve, right? So it's something to do with the interfacing, right? It's decoupling you and the framework. And it's a very important concept, I think. So back to this. So so here is the on-click add task method here. And basically, when you type in a task, right, you want to put it in a content value class. So you initiate or you initialize a content value class here, and then basically put the the description and everything that you need to put inside of the database. Now, this is very similar to what you're dealing with when you're dealing with bundles, right? So bundles are only it is only used for when you pass information from one activity to another activity. Bundles is activity based. Content values are database based, right? So you use content value to pass to put data into the content provider. You don't use bundles because bundles are used to pass data around inside between activities, right? So don't get those mixed up. And on your right here, this is all the methods for the content values. See, you can get Boolean, get doubled, get float, get integer, and then you can also put stuff into it. Now the put values, the put method are key value pairs, right? So you can, for example, like back to the hello task. So my key might be to do list items or something, and I pass in my string value, something like that. So it's a key value pair. So again, you have the URI here, and you pass it to the waiter, and the waiter goes to the content provider, and it stores the it stores the value. Now, in this case here, you notice that we don't have a Steve. We don't have a content. Oh no, it's not content. We don't have a loader manager here, and that is because we're only doing an insert. We don't care about the response. We only care about the insert. But of course, you can always get a return method here or something to tell you if it's. Oh, I think there is actually. I remember if a insert is complete, it will return a 1. If it doesn't, then it returns a negative value. I can't remember what that method's called, but in this case, we don't care about the loader manager. Is because it is only a insert, and we don't care about the response, right? There is no response because it's insert. So just one more thing. Inside of your app, you only get one content resolver. So the content resolver is a singleton. It is a global instance that you can get when you call the get content resolver, and you can always guarantee to get the same content resolver back. So it's the same every time when you call the get content resolver. So we covered the insert part. Now let's look at this. Now this part here is exactly the same as this, but what's different about this is that it calls the onResume callback from the activity lifecycle because it's coming back to the same activity, right? So one very interesting thing is that onResume is called, and then it calls the get support loader manager, and then it restarts the loader, okay? So again, this calls Steve, and then Steve, what he will do is that it checks to see if there's an existing loader. Now, by this point, if we follow the flow, right? If we just follow this flow, like start, and you add an item and it comes back, the loader should be still inside of the memory, right? It hasn't gone anywhere. Mm-hmm. So the Steve checks to see if the loader exists. If it exists, then it will destroy it. Okay. Now, if the loader is loading or it's doing its thing, it will stop it and it will destroy this. Okay. So a brand new loader will be created with no cached memory. And it will do all the loading background and then deliver results callback from the loader callback, right? So after that, this gets called. Now, there's a lot of confusions about this method, onload reset. So basically, onload reset gets called after this, after restart loader gets called. So restart loader, and it comes straight to here, and then it gets destroyed. Okay, so so it's loader restart, restart loader, and then it comes to the on loader reset, and then it nulls the cursor, which we'll see in a minute, and then it's then followed by destroying this loader here, and then regenerating a new one. So before I talk about this method, let's go and see how they constructed the recycler view, right?
So one quick question. Why does it destroy the existing loader? Is it so that it can refresh the screen?
Yes.
Like refresh everything? If it didn't, then it would just cache the old data?
Yes.
Okay.
So let's look at the recycler view for a minute. So in the recycler view, inside of the code, you got the code cursor, you got a context, right? Now, the reason why we need the context here is because this recycler view is tied to the main activity. You'll see this in a minute, but for every view that you instantiate programmatically, you always need to pass in a context, right? Now, why do we want to do that? It's because views needs a certain type of theme, right? Now, so if you go all the way up to the tree, you got context, right? And then it branches out to, I think it's a content wrapper. And then there's another branch that's called a content theme wrapper. And then it's the main activity. So the main activity inherits from a thing called the content theme wrapper. So theme is something to do with the UI, right? It's something to do with visuals, right? So by giving a recycler view this context here, now this recycler view can know what to do with the visuals and everything, like what fonts do I need to give this, and what's the default color and everything, right? So that's why we need this. We need this to call the super, by the way. So after this property, you got constructors. So constructor, this is wrong. This is wrong here. You don't initialize a cursor. I need to delete that. So forget about this. So the next three things that you need to override is the onCreate view holder, onBind view holder, and then get item count. Okay. And then of course you have your class task view holder, which you need for your onCreate view holder, right? And then you have a special method here that's called a swap cursor. Okay. Now let's look at this one. Now, the public cursor swap cursor, it's basically when you pass in a cursor, it will just replace the cursor here. It replaces this cursor. And that's all it's doing, okay? So a swap cursor method is a center method for a private variable that also returns the old cursor back, okay? And it is used in the loader manager callback on load finish. So let's see why, coming back to this, let's see why we need to do this, okay? And this is very important because if you don't do this, that means you're causing a leak inside of your memory, right? And you'll see this why in a minute. Let's go. Okay, does everybody know what a heap memory is? A heap memory?
I'm not super familiar with it.
No worries. So,
I know there's like heap and stack or something like that, right?
So stack, you can think of stack as kind of like where everything is stored as methods, right? So
Mm-hmm.
go to just a hello world Java program, just a hello world, right? So inside of that hello world program, you got this main function, right? It's called public static void main, right?
Mm-hmm.
So this main method gets called, and it's gonna be put into a stack. So you got your stack and you got your heap, right?
Mm-hmm.
So the main method lives inside of the stack, and everything, and I mean that everything means the local variable, all lives inside of that stack. Okay. Now, if you are trying to instantiate an object inside of that main method,
Mm-hmm.
that object lives inside of the heap. So the heap is like a playground for objects, right? Classes, objects, right? Instance of objects.
Instances. Okay.
So inside of a main method, if you say object obj equals new object, right? That obj is just the address that points to the heap memory. Does it make sense? So
Mm-hmm.
let's use this for example, right? So activity is a class, right? So
Mm-hmm.
it is an instance. So when you first load up your app, somewhere inside of the Android system, someone has to instantiate this class so that it will pops up on the screen, right? So it lives inside of the heap, like it has to. So
Mm-hmm.
now, because your main activity has an adapter and several views, right? They are attached to the activity through the context, right? The context theme wrapper, remember? Context theme wrapper. All of the views that you have, they all need the theme wrapper, okay? Because it needs to know what is the default size of the text, the default colors, fonts, and everything, okay? So it needs that context, and therefore it ties to the activity. Now, if you look at the adapter for the recycler view, you see how it's got the cursor property here. Can you see this?
Mm-hmm.
So you can say that the adapter is holding a reference to the cursor, right? I need this so I can function properly, right? You can think of it that way.
Mm-hmm.
So now, also the loader is caching this. The loader is holding onto the cursor as well. So you got two things that is holding onto the cursor. One is the adapter, and the second is the loader, right?
Mm-hmm.
Now, so you all know that when you have a portrait screen and you rotate it, activity gets destroyed, right?
Mm-hmm.
But you can't destroy in this particular example, this activity cannot be garbage collected. It cannot be garbage collected because something along this chain, someone is requiring it. Someone is grabbing hold on to it. And and this activity is not eligible for garbage collection. So that is why by setting this to null, by terminating this relationship between the adapter and the cursor, you are letting this go. Does it make sense?
Okay.
Yeah.
Mm-hmm.
You're letting this go so this guy can be garbage collected. Does it make sense?
Okay. Yeah, that makes sense.
Mm-hmm.
So, yeah, go on.
can I ask you a question
Sure.
regarding this? And so your instances of a class are loaded into the heap, right?
Yep.
Okay, and then you're saying that functions and or methods, which are kind of the same, are in the stack,
Yes.
right?
So, yep.
Okay.
Yep. So basically all the primitive types. So you got your int, chars, long, short,
Strings, yeah.
boolean, void.
Doubles,
Yep.
yeah.
They all live inside of the heap, the stack, right?
Okay.
So, for example, if I say object obj equals to new object, that obj,
Right.
that isn't your object. That is just a address.
Oh, it's a reference.
It's yes.
Okay.
Don't ever think that obj is the object. No, it's not. It is just a address that links to the heap. It
Okay.
located in the heap. So one experiment that you can do is that inside of your Android Studio, you can just say object obj equals to new object, and you try to print out that object, the obj. It will just give you an address.
A hex
address.
address.
An address, right?
Yeah.
It's not the object itself. The object itself lives inside of the heap.
Okay.
Oh, okay.
Right?
So
Okay.
what if something's static? Would it still, like, does that change where it
I
lives?
think
Or
static.
because there's no instance of a static thing, right?
That's a really good question.
Okay.
So I don't have an example with me, but you know how when they created let me show you this. I don't have the code with me. But anyways, what they did when they initialized the loader manager callback, they actually had an anonymous class as the loader, as the async task loader, right? It returns. I really wish I can show you the code. Hold on. Let me see if I have the code. Main Java res. Okay. Okay, just give me a moment, guys. Okay.
Sure, no problem. I'm actually going to step away just for a sec.
Yep. Okay, we'll just wait for Ryan to come back.
All right. So I want to. Well, he's gone. Oh, there he is.
Okay. Yeah, go ahead.
So you're talking about on a stack. So I'm going to try to. Boy, it's interesting getting used to doing video conferences like this. On a stack, so something gets loaded in, right, and then something put on top of that, and you keep going. So if you do run a method that you're saying is stored in the stack, are you saying when that method is done and either you return or it does whatever it did, then it's taken off of the stack?
Yes.
Okay.
Yes.
Okay, cool.
Is that for the purpose of garbage collection? Is that why the stack exists, or?
Well, I'm kind of new to this as well, but what I understand is that a stack is where all the operation lives. All the things that are related to that specific method lives inside of the stack. And anything that is anything object related. So for example, if you instantiate an object inside of a stack, that will be living inside of a heap.
Okay.
Right? So in a Hello World, for example, app, right? So you start off with the main method, and maybe you can have all types of methods on top of it. But at the end of the day, they should all get popped out, and the last one to go is the main method.
Right. Yeah.
And you were saying that the instances, they're basically pointing to an address in the heap. Sorry,
yes.
the things in the stack are pointing to instances in the heap.
Yes. Yes.
Okay.
And you need to make sure that as a programmer, you are not responsible for destroying objects in the heap, but you have to guarantee that that object is garbage collectible, right?
Otherwise, you have a memory leak.
Otherwise, you have a memory leak, like what we saw, where two things are referencing the same thing, and one tries to get destroyed, but it couldn't because somewhere down the link, someone needs that node, and then it's not eligible for garbage collection, right?
Without looking at the code, is there an easy way to? I mean, you really have to read the code to know that that's happening, right? Yeah.
I think there's a tool inside of Android Studio. It's called can't remember. I'll show you a link. There's a video that I can show it to you.
I'm gonna have to go for now, guys.
Sure.
Sorry, but I've got something coming up. So thank you both.
Yeah.
For having this. All right.
All right. See ya.
Thanks, Steven.
Yep.
See you later.
Yep.
Okay. Can you see my code?
Yep.
Okay. So this is basically the main activity for the task loader app, right?
Okay. Yep.
And if you go down here, where is it? Okay, here. You see how they do this? How they do all of this? Now, people say that it is a bad practice to do that because, first of all, this now to initialize a loader, you need to have a context.
Yep.
What this is doing is that it references the outer class. It's tying, this loader here is tying straight to the main activity.
Okay.
So that's one bad strike about this, and also, yeah. So this is really bad. So what people?
So this is the context it's using.
Yeah. This.
Okay. Yeah.
Yeah. This is the main activity context.
Main activity. So should they be using the apps activity rather than? That's one thing I've always been a little confused on is using the activity of the app versus the activity
of the context
of, or sorry, the context of the app versus the context of the activity. Like when to use one versus the other. I've always been a little.
Yeah. So what I gathered is that for anything that's view related, you always want to pass in the activity context. Why that is because let's say inside of your screen you have one view, one image view. If you were to pass in the get application context, right? The view never get, but what I understand is that it never gets destroyed. It never gets destroyed because in order to get that destroyed, your whole app needs to get destroyed because the application context ties to your app, right?
So something that lives beyond the life cycle would get
you don't want something, you don't want something that can potentially live beyond the view, right? It needs to terminate the life cycle together or before that, right?
Okay, that makes sense. So what would be an example of something that lives like where you would want to use the app
so maybe
context?
Something like I think I remember seeing some examples that is getting the battery status or something. Then you will pass in an application, like something that is really really low level stuff, like
I see
Wi-Fi signal or battery life or whatever, because they never get destroyed, right? Even though your app gets destroyed, your phone is still running, right? So in that case, you would pass in the get application context.
Okay.
For something that's view related, you would need to pass in the activity context, because activity context it extends from the context theme wrapper, and theme wrapper is UI related. Now, also the reason why this we need to pass in this keyword is because we want this loader life cycle to be tied to the life cycle of the main activity, and that's the reason why we put that in there.
Okay.
But what I'm seeing is that this is a bad practice. What you should do is you need to have a public static class. So instead of doing this anonymously, you would have a public static async task loader equals to new async, and then you do all your
I see
stuff.
So
now the main reason why we want to do this is because this doesn't let's not talk about this first. This is something to do with inner classes in Java. This is Java knowledge, right? So if you have an inner class, right? If you don't have the static variable keyword here, if you want to access the inner class, you always have to go from the outside in. So outer dot inner, right? You always need to instantiate the outer to get a reference to the inner class, and then you can access the stuff that's inside, right? So you have to go all the way up and then down, right? But if you put a static, keyword in there, what this is saying is that you can access this directly. So one benefit of this is that it doesn't tie to the outer class. So even if this even if this is destroyed, this can. Oh wait, hold on. So it doesn't. I'm getting a little bit confused. Hold on. So
no worries.
I can't remember why we want to do that.
I remember you can access things from the static object itself without having like an instance or something like that.
Yeah.
But
Can't remember. I think it's something to do with the fact that this is no longer tied to this. It's no longer tied to it. You can access it directly. can't remember the reason why though.
So remind me, what's the bad practice about the other one? Because we're doing a, we're making it anonymous, right? We're
Yeah,
doing it.
the reason why this is bad is because it's because of this, I think. It's because of this keyword. And this is related to this whole class here, this whole instance of main activity.
So as a result, does it make it so that it can't be garbage collected,
Yeah.
or what's the, okay.
It will tell you when you do something like this inside of Android Studio,
Mm-hmm.
you will have an error that says something may cause to leak, and then they would recommend you to use a public static instead.
Okay.
Yeah.
So doing it this way, you don't even have to use the this keyword when you reference it, or
I think you need to pass in.
you still need a context. It's just you're doing it differently, so it's not.
Yeah. It's something. I mean, you're right. This needs a context, but it doesn't. But to access this, you don't need to have an outside class like this one.
Right. Okay.
I can't remember the exact reason. I can't remember.
If you want to ping me later,
Yeah, sure.
yeah. But that it kind of makes sense though why you would want a static. I don't know exactly why, but just like from what we're talking about.
Yeah. Basically, the advantage of doing this is that you no longer require an instance of the main activity to get access to the async task loader.
Mm,
Where if you just do this, you can just access it straight away. I cannot
okay.
remember the full details, but I do have a link. I do have a resource for that, so I can send it to you.
Okay.
Yeah. And is there any questions that you want to?
I'm trying to think of any other questions. Let me think here. I think what you've covered so far makes sense. I'll probably rewatch the video and see if there's, and take some notes and see if I have any questions later.
Yeah, sure. Yeah.
But otherwise, like high level concepts, I think it makes sense.
Cool.
I feel like I have a little work to do on Java because I'm understanding it more, and I know about static now and a lot of those things, but there's still a little bit of a hole in my Java knowledge that I'm sure would help with Android.
Have you seen this book before?
No, I haven't actually.
I will give you a link to this. This is like really, 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 really good. This
Okay.
is really good. It's only like $16 on Amazon. So
I'll check it out. Yeah. Yeah, I got Barry Bird. He's one of the students with us,
oh
but
yeah,
he wrote a couple of the For Dummies books.
yeah.
And so I got his Java for Dummies. I haven't had a lot of time to dive into it yet just because of the
Okay.
course stuff. And then once I finished the course stuff, I've been working on some other classes related to Android. But I'll, send me a link. I'll pick that book up too and dive
Yeah.
into both of them.
Yeah. Cool.
Awesome.
Cool. Yeah, I got another meeting, so
Okay. Yeah,
yeah.
no, this has been really good. Thanks for taking the time. We also had a few other people jump on too. I think there was like at one point 4 or 5 other people. So
Cool. Cool. Yeah, this will be uploaded onto the YouTube channel, so you guys can rewatch it.
awesome. Thanks, Brendan.
Yeah, thank
Appreciate
you.
it.
Yeah, awesome. You're welcome.
All right. Take
Yeah,
care.
thanks. Bye bye.
Bye-bye.